Welcome back, everyone. We're on section 5 of chapter 11. We're going to do some more counting, throwing in permutations and combinations, and we'll see what interesting things we can run into. Permutations, remember the order matters on those. Combinations, order does not matter. So here we go. All right, I guess we're at the Old Folks Comedy Club. We've got 6 comedians, comedian in one case. We're going to pick those comedians and we're going to throw the cards in the hat, drawing them one at a time. We're going to listen to all 6 jokes. We want the probability that a man's joke will be delivered first and the woman's joke last. So here we go. Let's grab the pen in case I need it. Don't think I'll need it though. So here we go. 6 jokes. 5 by guys, 1 by a woman. Phyllis Diller. Here's how it looks like. We're going to get the number of permutations on the top, with the man's joke first, women's joke last, and on the bottom, the total number of all the permutations. And this is sort of how it looks visually. First joke, second joke, third joke, and so on. And the last one, of course, by Phyllis Diller, the woman. Since there are 6 choices, and we're going to pick all 6, it's 6 factorial, and there's 720 permutations. So we'll find the number of permutations with a man's joke first, woman's joke last. With that restriction, we've got 120 ways that can be done. 121 ways that they can all tell their joke, and the woman is last. And on the bottom we'll have all the ways that all those 6 could be placed in that list of joke tellers. Notice that was 1 over 6. If you like to, you can make that 0.1666. That will be the probability for all those jokes to be told, but the woman is telling the joke last. Phyllis Diller. Next, Powerball. You ever play Powerball? You know someone that's played Powerball? It's the first game, apparently, to be a lottery and draws numbers from 2 drums instead of 1. Here's how it goes. Now, this isn't from memory. This is because this slide tells us this, but the way it works is you choose 5 different numbers from 1 to 59, and then 1 Powerball number from 1 to 35. So you're choosing 6 numbers, 5 in the first group, 1 in the second. Twice a week, they pull 5 white balls. Those are the first ones you're going to pick. And those are 1 to 59, as we mentioned up here. Then we pick a red Powerball. It's drawn randomly from a drum with 35 red balls, numbered, of course, 1 to 35. You win the jackpot if you get all 5 of the white numbers in any order and match the red Powerball. You pay $2 for your ticket. What's the probability of winning the jackpot? Let's see how this goes. The order of 5 matters, does not matter. Does that ring a bell? Combination. Situation with combinations. So we begin the formula for the probability. The number of ways of winning over all the possible combinations. So here's our combination. 59 factorial. Of course, you can do all of this on your calculator, so you don't need to have to do this, but you can see how it's done. Notice that the 54 factorial and the remainder of the 59 factorial all cancel out. You still have the 5 factorial on the bottom and the 59 through 55 factors in the top, giving you a total of just over 5 million possible ways of winning. But that's not all of them. We haven't mentioned the red Powerball yet. There are 35 red Powerballs in the second drum, so that's 35 possible ways you can pick the right one there. So, using our fundamental counting principle, we multiply that combination for the first 5 Powerball numbers, the white ones, multiply it times the 35 different red Powerball possibilities, and we've got a total of 175 million combinations. Remember, you pay $2 to play. Only one combination wins. So there's only one way of winning the jackpot. So 1 goes on the top. The total number of possible ways you can play, or yes, play on the bottom. 2, the arithmetic, calculator most likely, and you got a pretty small number. If you want to change that to a percent, it's still awfully tiny. That gives you your chances of winning the Powerball. Let's take a look at another example. We've got a club that has 5 men, 7 women. We're going to pick 3 members at random to go to a conference. Find the probability that that group consists of 3 men. Got an idea on that? Here we go. There's a 5 men, 7 women. We're going to pick 3 from the 5 men. Solution. Well, it doesn't matter what the order of selection is. Either you're going to the conference or you're not going to the conference if you're one of the guys or one of the women. So the probability of 3 men is, first of all, the number of ways you can select 3 men over all the ways that 3 people can be selected. Since there are 5 men and 7 women, what's the probability that the selected group consists of 3 men? How do we do that? Well, number of ways you can get 3 men over the possible combinations. So to get those 3 men, or 3 people rather, out of the 12 that are in the club, is a combination of 12 people taken 3 at a time. And this is your formula, but you can use the calculator to get 220 possible ways those can be chosen. So the 220 possible 3-person selections, but that's any 3 persons, not 3 men. We want 3 men from the 5 men. How many ways can we get that? Because that's going to be in the numerator. Again, it's a combination because we don't care about the order. Combination of 5 things, and we're picking 3. Use our trusty calculator. We wouldn't have to, but we could. We get 10 ways of choosing 3 men out of the 5. And the probability of 3 men overall, 10 ways of getting the 3 men out of the 5, and all the possible combinations, 220. Reduce that a slight bit, and there is our probability. You could change that to a decimal or to a percent if you like. It would be a little bit under 5%. All right, we've wrapped this up, and we'll see you again in section 6.